It's the limit comparison test. Wait, how do we even know? Because we have the quotients of two polynomials, aka a rational series. So when we see something like this, we want to use the limit comparison test. So we're going to let an be our series, the one they gave us. And then our bn, that's going to be 1 over n. How did you know to choose that? Because I take the quotient of the leading two terms. N squared divided by n to the third is 1 over n, and that's how. Now, I take a look at the limit as n goes to infinity of an divided by bn. But some of y'all may have heard that rhyme, that hum, that hymn. Dividing by a fraction is the same as multiplying by the reciprocal. So I flipped it like a gymnast. Now I'm going to multiply that guy in there. Multiply at the top by n. That's how I got that green 3, that green 2. Algebra. And then we run that limit. We could L'Hopital. We could use L'Hopital's 3 times, because that's infinity over infinity. But why don't we do it algebraically? So we divide by the leading term. Yeah, everything. I divide everything by n over 3. And I'm going to reduce 2. Because n to the third over n to the third was 1. Minus 5n squared over n to the third is minus 5 over n. The reason why and when I did that is so that now I can evaluate that limit, because all the over n's go to 0. You go to 0. You go to 0. And you are left with 1. I will call him Neo. So what does that mean? Since that limit as an over bn equals 1, and since the series 1 over n is a divergent harmonic series, then by the, which test are we using? Limit comparison test. That series, they do the same thing. Since that one diverges, this one diverges. And it's all over but the box and flower.